Next question is to find the Norton equivalent circuit of the circuit shown in figure at terminals A and B. 6 ohms, 10 ampere, plus minus 2 times Vx, 2 ohms, and Vx is given across 2 ohms. So we need to find the equivalent circuit across A and B. So steps are same how we go for Thevenin's theorem. So first we'll find Vth. Looking at the diagram, whatever voltage Vx is will be the voltage VAB. So I can say what is your Vx, that will be your VAB, and that will be your Vth. That is the Thevenin's equivalent voltage. So for that I'll do source transformation. Current source in parallel with resistance will be converted to a voltage source in series with resistance. So I'll have positive negative, then the resistance 6 ohms, and this V will be I into R, so this will be 60 volt, this as it is, plus minus 2 times Vx, then here you have 2 ohms and plus minus Vx. Applying KVL in the loop, we'll get 60 minus 6i minus 2 times Vx minus Vx is equal to 0. Now from figure I can say Vx is 2 times I, assuming the current is flowing as I, so Vx is 2 times I. So I'll substitute this, substituting 1 into and solving, you will get the value of Vx as 10 volts. So once you know the value of Vx as 10 volts, you have already found the value of Vth. So I've got Vth as 10 volts. Next is to find the value of In. So for that we need to short these two terminals. So the equivalent circuit will be, for finding In, the equivalent circuit will be (10 amperes, 6 ohms, plus minus 2 times Vx, 2 ohms, plus minus Vx, and terminals A and B will be shorted and the current flowing will be In. So from figure, if these two terminals are shorted, this resistance becomes redundant and Vx is 0. When Vx is 0, then 2 times Vx is also 0. So from the diagram, this part will go, only 10 ampere is left behind. And if I apply the KVL also, or straight away I can say 10 ampere In will be my, from the figure I can say In will be 10 ampere, since this is a resistive branch and this is without resistance or short circuited branch. So maximum current will flow through this, and this there will be no current across through the 6 ohms. So total current 10 ampere will flow through the short circuit branch, hence In is 10 ampere. So I can find from this, I can find Rn or Rth, which will be Vth upon In. So it will be 10 volts upon 10 amperes, so it will be 1 ohms. So Norton's equivalent circuit after solving will be like this. Between terminals A and B, current source In 10 ampere and resistance Rn as 1 ohms. So this is how the Norton's equivalent circuit is drawn. This is Norton's equivalent circuit. This is how we have found the Norton's equivalent circuit between terminals A and B.